All right, first of all, I want to thank Johan for organizing such a wonderful symposium, the second bamboo square and geometry. And also so nice to see many of our friends, Paulo, Dudley, everybody here. And also the first lecture was inspiring, fascinating, and try looking for a model to reality, which is a very challenging and also exciting area to do. And when we model a particular object, so we may see it right away when you try to model the reality and start from a void. A really important message from Fred. You enjoyed his talk and looking forward to read his book. And also, I remember Johan wrote a review about his book in the Symmetry in the Science and the Culture. So that's wonderful. And also, I want to apologize that I won't be able to be on the day 2 because I will be at the university for our final exam. So for those that giving a lecture on the day 2, I'm sorry I missed your lecture, but I will capture in the recorded sessions through the YouTube channel. So, I have a quick 40 minutes to do my presentation. So here's these are the thinking notes that Johan and I we have been communicating and looking for also sort of our understanding about human thoughts. So the title, as you see, is looking for some of the geometrical patterns or our thinking about roots of thoughts and also connection with the zeros of mathematics. When you talk about the zeros, you will connect to the void, empty set, and the nothingness. And also when you talk about the thinking, we're thinking everything. We think in numbers, we think in geometry, we think of physics, we think small, we think big, we think of past, we think of future, we think everything. So thinking is a wonderful thing. So if we don't think, we are not here. So we are who we are thinking. So that's the message. So let's begin with a couple of bamboo tea with us. So I'm thankful for Johan introduced me to the concept of bamboo. Also, he showed me his wonderful geometric garden in Holland. And the bamboo is evergreen, flexible, durable, and also symbol of simplicity and the continuous growth. So bamboo teaches us patience and persistence, and also teach us how to approximate nature too. As the ingredients of a happy life, bamboo stem emerge as a sort of a roots of humanity in some culture. So here's the convergence towards the idea through the bamboo trees. And I see that the bamboo trees are growing and I see a little bit of shade of light where that they're looking for the trees of a brain and roots of the mind. And first of all, whenever I give a talk, I always ask myself some of the fundamental questions. What is the matter? And what is life? And what is information? So now what is mind? So this is the fundamental questions we like to ask. I say whenever we're thinking. So when we think about our organ, the brain. Our brain is an organ of meaning. So in my thinking, certainly we all think differently. We think no two minds are the same. We think differently. The brain is a mixture of A and not A. So that is the individual and the general. So every thought has its own mathematical abstraction. So there is numbers, geometry, there's a relationship between us. And so we are thinking, so to answer those questions, so we human beings have been exploring what is matter for a long time. And the recent discovery of a double helix was a question from what is life. So nowadays we are thinking what is information in psychology, in cognitive informatics, and many other domains, we asking what is mind, which is a huge question. We may never know, but we try to understand ourselves. We try to do approximation. So in my own field, I'm a mathematician. My field was approximation. I always think about everything we do is sort of approximate. We use the discrete idea to approximate continuum, but so we try to explore something we don't understand. So question now becomes that what I cannot create, I do not understand, which is by Richard Feynman. We all know him. He's a physicist, and he won the Nobel Prize in physics. And one of the motto that you and I we share is that unity in multiplicity, diversity in unity, and all those things are all connected in one. And when I see the picture in my slides, left and the right, and I see they're the same thing, but in different ways. So we try to see the pieces, we try to see the whole. So what is parts? What is a whole? Is a whole bigger than sum of the parts, and how they're working? So this the picture I would like to share to see the issues and see the object, see the potentials, and see the things, how things are working. So I have 3 parts. I will quickly move on. The first part is 3 principles of a brain-mind relationship. And the second part, universal structure of human thoughts. And third part, so think about the thinking kernels and the zeros of mathematics. So basic idea is that I try to looking for 2 boxes and also connections. One is a black box inside our brain, and also something expressing ourselves, that's open box. Then between those 2 boxes, what are they? So is there a connection between them? To see the connection between them, perhaps we need to look for some mathematical patterns. So the most hard part is a black box inside of it. So the 3 principles. So recently there is a book by a colleague, The Trees of Brain and the Roots of the Mind, published in 2015, very recent. And the biggest challenge to understand our brain is the connecting subjective experience, which we do every day. We observe, we argue, we think, we talk, we do everything, and with the shape of forms of our nervous cells, the neurons. So that is so now we look at the specific neurons, so has those basic structure according to current neuroscience. There's a cell body, then also communication channels, dendrites, axon, and also a terminals. So when you look at this, we try to see the nature. On the left, you will see a tree in the forest. There's lights in it. That's outside of brain. We have that. And then also another picture that's our nervous system that's inside our black box. So then below that is our exploration. Can we connect them? So what are the relationship between the neuron inside of black box and outside the forest? What are we doing? So look at specifically the membrane potentials. And I heard from Fred talk about also different type creative potentials. So where they come from? Is there a root from that? So if you look at this specific neuron models, see those connections. There's a membrane protect the cell body, the soma, and there's an axon to communicate the signals when we then try to receive the signals. And also myelin sheath is try to protect or communicate all the chemical particles within. And also terminal buttons will connect to other neurons through the synapses so that everything will be connected. So when you look at those membrane potentials, broadly, the understanding is that there are three main kinds of potentials. So when we sleep and when we rest and when we don't do any active thinking, perhaps we are at a resting potential. So that can be measured within a certain range. As we actively engage with our thinking, and it becomes a graded potential, so we'll reach the action potential. So action potential where the sparks taking place. So when that sparks taking place, is there a pattern? So what are those sparks within our brains? There are millions, billions of brain neurons. So they all make a connection. So the sparks are all over, and we're looking forward. So all those potentials, particularly action potentials, we care the most. But without a resting potential, without a grading potential, we'll have no action potentials. So in terms of logic behind those potentials, the resting and graded potentials are in analog mode. So they move almost like continuously. When you reach the action potential, it's all or nothing. It's almost reached to the binary scenario, to the stream. So you take sparks. So now all those actions taking place with the binary logic within different potassium, sodium, the gates channels will open, close, and also exchange the components between those, say, a potassium, sodium. What is interesting is that within the cell and internal, external, the cell exchange is a 2-to-3 ratios between the potassium and sodium. And with that kind of differentiation allows the potential and also allows us to see the differences. So which is a very interesting ratio. We see that the analog side of a resting graded potential and also digital side of all or nothing, the action potential. So that is a quick catch on that. The first principle of a brain and the mind is that the patterns of neuroelectric activity, also chemical activity, which correlates to the mental states. So, which is one of the important principles, the way we think is connected to how the neuron sparks, all those electric and chemical activities within our brain. Any thought we do, we think all differently. We think at macro levels, the emotions and all the physical particles will intervene how we feel, how we imagine. So those sparks really has a great potential for us to understand what is going on. The second principle of the brain is important that as a human being, there is a capability of learning. Learning is a wonderful thing and also challenging. How do we learn? How do we memorize? How do we make sense of things we observe? So within the nervous system, the learning is the acquisition of potential to restate the previous unknown mental state corresponding to the change of connections in circuits of the neurons. So learning acquisition give us synaptic connections. When a synapses forming or eliminating requires that's a part of our learning. So without those synaptic connection, we lose the learning connectivity. The third principle has an interesting area where that axonal dendrite overlaps. These overlaps are important because without overlapping, you won't be able to have a potential synapses. So which is where that the neural correlates the capability of learning. So this is where that how do we know when and which neurons will do firing, when they will be firing. And there is quite a bit of study in the neuroscience in this direction. So continue on. So that's a brief, quick walkthrough of the inside the black box. Now, outside the black box, which is open box. So the people in psychology, they want to model our thinking structure, came at a following 8 perspectives of thinking expressions. We express ourselves, we publish, we talk, we say something, so sometimes we think we may not say things, and sometimes we think we say things, sometimes linear, most of the time non-linear. So regardless of what it is, so when we see what we have published or we have presented, so it has been summarized as 8 possible scenarios, ranging from a purpose of questions, information, and concepts, assumptions, implications, and a point of view. So this is a model, also as a model, as a universal structure of a human thought outside of a black box. So this is an open box. We're able to see, we're able to express ourselves. And how do we connect them? So that's where the early studies of cybernetics comes in. So look at what is the inputs through our 5 senses: sight, hearing, touch, taste, smell. So then those things will be selectively got into our black box. Our black box has the ability to select those information and process it. As Fred mentioned, that everything is a process. So the process is hard to know. So what's inside of this black box, how things are processed. So that is where we have been exploring. So what is there? How, for example, what is the time? Do we have time? Is the time a clock measured? Is no. What is time? So according to Fred, time is a totally ordered matter. So that's very important. So that's the cybernetics as a communication, as a mirror of the thought. So now, human brain, so we come back a little bit to the black box. Human brain actually, Douglas Hesford said that in the end, we are self-preserving, self-creating, locked in mirage. We are miracles of self-reference. So what is the equation of self-reference? So here's my explanation. It's the fundamental theorems of a self-reference paradox. So it is A equal to not A. If you do a little bit of calculation, it turns out it's a middle point, the truth value between 0 and 1. So the black box is in the middle. It's the middle, so we do not know where to go, but it's at the center of this discussion. So the centrality of thinking, certainly when you look at every part of a brain, different lobes, different distribution and allocation, what they do each part. This has been documented, has been imaged to see where each lobe is doing its job, particularly the frontal lobe, where our thinking and speaking, even I'm doing now, my frontal lobe is working. And so I do my movement, I collect my memory, I express myself through that particular frontal lobe. Now, so brain is an organ for many. As you see, there are 6 main functions are described with the location of each lobe with corresponding to the functions. Each one is important. So there's an area for hearing, there's an area for vision, there's an area for standing. There is everything is inside these little mystery organs we are here today. So that is a centrality of thinking how things are supported. So move on, the last part of conversation, that is a thinking kernels and zeros of mathematics. So again, this is a very limited. So the first thing is that I think that the brain is a mixture. We are a mixture of a conflict. So conflict is a paradox. It's a law of identity. We are ourselves. It is a we're in the black box in the middle. Is A equal to not A? So when we argue, because in mathematics, the middle has been excluded. So actually the middle is so important. We excluded them because we want to make a decision, yes or no. So we forget about that. So thinking kernels, I here refer that as a spikes or intersections of neural synapses. So thinking kernels is intersection. When you think about intersection in mathematics, so two things connect. We solve equations. We look at the critical points, the inflection points. We look at the algebraic varieties. We look at the solution to the system equations. And regardless, any equation is a part of zeros. Even inequality, zeros comes into play. Simple example, we all know. The zeros of a unit circle. Circle is a human innovation that the unit circle, as we all know, it's uniformly distributed on a boundary, which is separate internal and external. Now, so we mentioned that inside the black box, there's a different potentials behave like analog. So it's a fuzzy. It's not like action potential 0, 1. There's a sort of a logic within our thinking black box. I labeled that as a binary logic, which is simply connecting the binary and fuzzy logic. So here's our proposal. We propose that the mind as a motion matrix of a matter, which is a structure, and a meaning. So which is can be a use information to describe, perhaps, and also energy, and which is emotion is energy in motion. So those three things are fundamentally basic elements of the human mind. So three things, structure, things that we sort of be able to observe, and the meaning information, we try to describe it, which is sort of a invisible. So matter is we're able to observe, and the information meaning, what do we mean? What are you thinking? So we really try to make sense of it, which is we cannot see what's inside the black box. So which is sort of a pair of a paradox. Visible structure, invisible information, then connected by both visible, invisible of emotion. So emotion can be both direction. So it can be yes and no at the same time. So go back to the pattern. So now we're looking for the pattern. So there's a book by Grenander that introduced by Johan to me, that calculus of ideas, that looking for patterns theory of a mathematical study of a human thought. So a couple of things that I put over here. So I just want to pick up a couple of important ones. One was interesting one that catch my eyes, that human thought has a geometric structure. So that is one thing. And also point out that the mind can be implemented, again, approximated by biocomputing, which is what currently biologists, physicists, chemists, psychologists, philosophers are trying to explore what is thinking. So, and also here that thoughts are made of discrete entities, ideas. So ideas, so his idea is that, let's say, what is a thought? The thought is more like a collection of, or maybe ordered or unordered elements, which call that ideas. So I will not go through those, but I will just point out a couple of things that will be useful for this lecture. So now the logic is behind is a fuzzy and a binary combined. There is in the binary world, Lofty Zidach. So he passed away. He's a father of a fuzzy logic. So he early time he had a publication back in 1999 where it deals with the fuzzy logic. The binary, as we all know, it's one of the approximation today we are using to describe numbers. So manipulation of measurements. We use those things, so which is a part of your brain where the sparks, the action potential take place. And he proposed the fuzzy logic, basically is thinking with the words. So thinking with the words is say in the arena of manipulation of perception. So how do we manipulate what we're thinking? So that's the most difficult one. So what we did a little. We did so tiny things about the binary, so much ahead of us what is a manipulation of perception, which is a part of a strive of fuzzy logic. So the thinking is that the binary things that we limited the knowledge currently, we got a 0, 1. So fuzzy things that we sort of, we running between extremes from past to the future, from small to big, whatever those extremes we do that, so you set up a sort of a frame with a binary as an extreme and fuzzy in the between. And when you have those fuzzy lines, there's intersection kicks in. So those intersections can be thought as thinking kernels. And certainly, whenever it's intersection in mathematics, we connect that to the zeros. So 0 is not just a nothing, it has a potential meaning to it. So it's a generative source of meaning. So like Fred mentioned that if there exists, where's the non-exist? So 0 is not simply nothing. It has a most dangerous idea in mathematics. It has occurred. In fact, in terms of the numbers, 0 came the last. 1, 2, 3, all those integers might be reals came earlier, 0 came last. So that's interesting evolution of the numbers. And there are many properties you can think about the thinking kernels. So it's happening inside a black box. It's internal, not external. And also during the process, again, the process is everything. There's all the different kinds of processes are going on between old thinking kernel to the new thinking kernel. Old connects the new connects old. And all those become a part of a process. Perhaps there is a order within our thinking. So maybe order is totally ordered or unordered or chaotic or ordered or stochastic or probabilistic or deterministic. We do not know how that order is. So the motion itself is a thinking kernel, and the different self is a thinking kernel. So basically, thinking kernel behaves like a zeros of mathematics. It binds us to make a communication. So here's the quick slides of show. I look at the ideas. What is idea? We say that the thinking is made of ideas. So the ideas is a reflexive and a spontaneous manner. So which is by Plato early time, they discussed studied ideas, what idea is. So here's that I sort of approximate idea as a point with the 3 fundamental primary entities of a shape, number, and a relation. There's quite a bit of story here. Johan told me the story about number and shape. So when he was visiting Brown University, and is there a number within the shape? Answer is yes. And now is there a relation between numbers and the shape? And that's the idea. Without the relation, without the shape number, you won't be able to form an idea. So the mind space is a dynamic collection of ideas with abstract space where ideas can be ordered, unordered, commutative, or non-commutative. So this is the space we are very limited to. So here's a little bit of geometric shape, but in fact, this graph, as you see, there are 1 point on the upper right corner, use little p to represent, and quickly I will know it's a conjugate. And also I know it's opposite, 1 minus p conjugate. So through 1 point, 4 points came to the picture. So I use that as idea matrix, P 1 minus P conjugate with the 1 minus conjugate. So that becomes the idea matrix. It's a 2 by 2, very simple matrix of idea. And so now it is a reflective, it is a spontaneous, and it has both opposites and connects. So what is interesting that I put this into a sort of a critical strip. So in mathematics, we all know Riemann hypothesis, conjecture. There is a critical strip. So the critical strip, we still have no idea where those zeros are. So basically, there's a middle line. That's where the half is. So that is a idea connecting to this 2 by 2 matrix. So put it into a little box where the thinking kernels are. Actually, thinking kernel is in a middle line and an intersection. So whenever we have neural sparks, and when we say the new axon or dendrites connects, has to be a spark. Where's that spark? So here's the intent to try to see the inside this idea matrix. The thinking kernel is at the intersection. So intersection is that we put this critical line. So all intersection point on this critical line and form the thinking kernel of the mind. So that is a proposal. So now the simplicity. So as we know, the thinking is continuous. It's not a discrete. So mind as a motion of a matrix and a matter, meaning and emotion. So geometrical language currently we are exploring is a Pythagorean type. As you see, whenever you see that little matrix, it's a square, triangle, circle kicks in. So the Pythagorean really kind of give us idea the relationship between numbers, geometry, and relations over there. So now there's a Lim and Gilliard's transformation. Those are shapes much closer to the nature. So is there a super ellipse in our thinking mind? Is there a transformation within it? So this is the exploration we are thinking. Move on. So early time when I did some studies about the information, so one of my fundamental questions was, what is the information? Still, we don't have exact definition. We don't know what the information exactly is. So now we're back to data. So data is a small unit, a chunk of information. Then information become data, add a little bit of meaning to it. So that's the sum of definition. So now we move on to the knowledge. So it becomes a process of data to information to knowledge. So data is sort of like a black box, and knowledge is outside the box, and information is in the middle to connect both. So that's a early publication on the central dogma of informatics. And basically, it is a process of replication within the data and the transformation in the information, and eventually come to the application in the knowledge. So that's the fundamental ideas of a central dogma. Now, today we are working with the global brain, so the part of a sort of a part of a reality. So global brain is a self-organized system, and where that different connections, information, and technology. So that's just aside. So not my interest there. So the modeling between the brain and internet brain. So this guy here is inside. This is outside. So we try to do reverse engineering. Can we say something about the inside from outside? So if we probe inside what this guy is doing, so we may project what's happening outside. So it is a self-organizing system as a global brain. So here come to the last piece of a talk, the central dogma of thought. So here's the proposal. So the thinking kernel as a source of thinking, we're thinking differently. We think about the time, we think about the space, we think of different things. So has to be where there's a center. What is the thinking center? So the center of thinking is a kernel. So within the thinking kernel, there's a lot of process within it. So there's a replication, reflection, reiteration. Sometimes hidden, sometimes are expressive. So that's the most difficult box to study. And outside the box, we're able to see, look at last column, thinking of expressions. So where that we're able to represent, we're able to interpret, and that's a part of a translation process from what we are and what we do. We use different languages, different communication skills to do the translation. Now, between the thinking kernel and the thinking expression, there's a thinking flow. That's also challenging. That's where we say transformation. How do we able to connect? Is that one-way communication or two-way? Can we go back and forth? Maybe not. So right now, so we're able to see some of the thinking might be came out from a black box to the outside. So we are looking for some conversion. So conversion or transcription and the transmission, so that we have a little bit of understanding what's inside a black box. So the central dogma is stated as following, is that the thinking process from a thinking kernel of internal black box to thinking expressions of external of a communication open box via the middle transmission of a thinking curves and flows. So lots of open questions. And but it's exciting. We try to understand who we are, what we are thinking. We are thinking, we're producing. And in the end, I want to thank you all with the beautiful bamboo, flexible, durable bamboo canopy and bamboo instruments from inside a bamboo house with the flowering bamboo, seldom, and hidden kernels in bamboo geometry garden. And thank you all for all your attention. Johan, you're muted.
Yeah. Is it possible to ask you a question?
Yes, please, Peter.
Okay. But I have you have mentioned the Riemann hypothesis, even do not explicitly. What have ideas to do with Riemann hypothesis?
The Riemann hypothesis is that so you have a start from a harmonic series, and you do analytical extension. You got a very special zeta function. Zeta function has a very nice feature where has lots of philosophical nature hidden in it. And so what's happening is that the conjecture is that what is the zeros of a Riemann function, zeta function? The hypothesis that the zeros are lying in the middle line, that the real part of z is a half. The critical line is between 0 and 1. 0 is a 0, 1, as you know, is two extremes, 0, 1. So zeros are inside the critical line, which is in the middle. Also, that those zeros connects to the prime numbers. So it has been a for many years, since 1800, it becomes the most famous mathematical conjecture.
What again, Reed?
No, yeah,
that's what I see, but I cannot prove it using current mathematics. But I feel that it is true because everything has a in fact connected to the quantum mechanics. It's also said it is a connection between discrete and continuous spectrum, because prime number is discrete. And however, the Riemann hypothesis it connects to the continuous nature through an imaginary number I. So imaginary number I is a monster. So it connects the real to imaginary. So which really is part of thinking, where that Riemann able to get the geometry of it.
Thank you.
You're welcome.
So can I also ask?
Yeah, sure.
Yeah, so you said the brain is self-organizing, but if you look at the gut bacteria, they act on the brain via the nervus vagus. They change the brain, tell it what to produce. So I don't think the brain is self-organizing.
Yeah, there's a open question whether the brain is an open system or closed system. I think that it's both. It's evolving, it's changing, organizing in dynamical fashion. That's my current thinking. It cannot be closed, but it cannot be open. It is open, but it's in both. It's both closed and open. That's a mystery. That's a paradox of the brain. It's organizing and unorganizing at the same time.
But the gut bacteria can create some serious diseases. It's Parkinson, very much experience with nowadays, is created by the gut bacteria. And they tell the brain to produce nuclein instead of dopamine. So the brain behaves as the gut bacteria want.
Right. So it becomes an organ where some function can continue on, some function will degenerate. So it depends on the conditions. So that's where the open system kicks in. Not simply closed to do your own job. It's a connected.
Okay, can I tell you another story about unconscious thinking? I had a student, Rudy Penny, he was mentioned today already, and he was working on a problem in robotic fingers, geometric problem, and he was doing his military service, and he told me his problem did not continue very well. And I went to bed that day, and I woke up the next morning, and I saw the complete proof in front of me. I dreamt it, and I saw it in the morning. I went to the university and explained it to the first people, some PhD students, and it turned out to be correct. So I didn't even think about it as far as I know. So it must have been unconscious. So we still think, as obviously not fuzzy, but logically, while being asleep. Can you explain that?
There's you see, there's outlier, there's a norm. So one of the story you mentioned, this interesting story because it reminds me interesting mathematician, Ramanujan, Indian mathematician. He does all the mathematics while he's sleeping. And not only that, and he will come out a infinite series of formulas without doing integration or differentiation. He's able to come to that point where that the formula is that. And later on, people proved it, his formula. He came out with this formula while he was sleeping. So sleeping that's another area. So the resting potential. So although is there a thinking? So is what kind of thinking is that? Right now, I kind of thinking the action potential. It gives us a thinking kernel. Now the without resting potential, without graded potential, we'll have no action potential. So perhaps there's a stage of thinking to reach the action potential, even we are sleeping. In fact, when we are dreaming or resting and actually thinking never stop. So that is, it's a continuum. It's like, sort of like when you describe the reality, that's something huge. Thinking is huge. So it is what a reality we do not know. Yeah.
Yes, that's true. I guess it was the impression that we were thinking completely logically and everything without knowing. I think the problem is the awareness of the thinking. And it is like if you put a finger in streaming water, you feel that it's streaming. But if you take the finger out, it's still streaming, but you don't feel it. So the brain activity is not fuzzy or anything. It's just going on as it is, aware, but then non-aware. So the awareness is also some brain activity to control the streaming of the water, let's say. Is that a good explanation, perhaps?
Yeah. I think that aware, not aware. That's also when I read some of literature in philosophy, there's quite a bit of discussions about awareness, how consciousness, subconsciousness, described into many levels of consciousness, and aware, unaware, and how that still is a debate on that. I think that the way you're thinking, aware, not aware, internal, external, we feel, not feel, those are many things that we do not know. So so that is a exciting part too, but it's a curious about it. So that's also you're right. Yeah.
Make two comments. So
Can I add another comment on this point?
Please, Peter.
Yeah. Oh, thank you. No, I would like to just to comment on one point about and I have always been fascinated by this way of thinking, and I came with a point. The point is the following: in mathematics, there is something which is based on the relationship with analogies rather than relation. So there is a kind of permanent, there is the principle in which the formal relationship remains the same independently of the nature of the problem, but the point is just to find the right analogy. This is what Greek mathematicians do. And I think that when you have established an analogy between entities, then you are able to translate it to another entity and so find new formulas which are in reality an old relationship which has been only translated, no matter what.
Yeah, I agree. In fact, I think that whenever we touch any subject, anything we do, we already limited ourselves, because we try to define the time. What is time with a minimal effort or minimal information to do it? So whenever we touch one thing, we already limit ourselves within. So that's the nature of it, because that raises the question: are we able to have a theory of everything? So that's what the question is. So whenever we do something, even to mathematics or physics, whatever we do, we already put ourselves into a limited capacity. Okay. So the huge capacities out there will never, maybe collectively, but whatever we do, there's assumption in it. So that is a struggling we are having. Yeah.
Thanks a lot. Very nice talk. Congratulations.
Thank you.
Maybe
thank you.
like